In this video, we're going to be looking at linear equations, the different forms of linear equations, and how to write the equations of lines. So before we can really talk about writing an equation of a line, first we need to be able to identify the slope of a line. So if we're given 2 points, x sub 1, y sub 1, and x sub 2, y sub 2, we can find the slope by taking the difference of the y's in the numerator divided by the difference of x's in the denominator. Now, one thing to note is when you're taking the difference of these 2 points, if I start by using my y and my y sub 2 in my difference, I need to also start by using x sub 2 in my difference first in my denominator. It doesn't actually matter which point you use first, as long as when you do y sub 1 minus y sub 2, in your denominator you do x sub 1 minus x sub 2, or the other way around. If my denominator is 0, then we say that the slope will be undefined. And this happens when we have a vertical line. So vertical lines have an undefined slope. So what are the different types of lines that we could experience? Well, we might find a line that has a positive slope. So positive sloping lines look something like this. And we would say that a line with a positive slope is increasing, which means as I move from left to right, the y values are going up or increasing. A negative sloping line would be maybe something like this, where as I move from left to right, my y values are descending or decreasing. Whoops. D-E-C-R-E-A-S-I-N-G, decreasing. So an undefined slope, like we said, comes from a vertical line. So vertical lines like this have an undefined slope. Vertical. And zero slope means that the value of the slope is 0, not that it does not have a slope. So no slope would be something like undefined slope, but zero slope means that the value of the slope is 0, meaning it is a horizontal line like this. This would happen when the numerator is 0. So this is a horizontal line. So horizontal lines have 0 slope, vertical lines have undefined slope or no slope. Positive sloping lines are increasing and negative sloping lines are decreasing. So what's the difference between a vertical and a horizontal line, other than one goes up and down and one goes side to side? They have some special equations. So vertical lines are going to be an equation where it's going to be x equals and then some number, some constant. And the reason why a vertical line happens like this is because let's consider the vertical line that we have here. This line, if I were to pick any point on this line, let's say this point here, my x-coordinate here is going to be the same as my x-coordinate there, or my x-coordinate there, or my x-coordinate there. Every single point that lies on this line has the exact same x value. And thus, that's why we have this equation here. It says for any y, x is equal to this. Since it doesn't reference y, that implies that all y's exist, or for all y's, this is my x value. So this is going to be a vertical line. And remember that your vertical lines have an undefined slope. Horizontal lines all have the same y value. So again, if we look here, if I were to pick any point on this line, my y value is here. Here's another point on this line, this point on this line. All of those points on that line have that same y value. And if you were to plot all of the points that have a y value at a specific place, they would give you a horizontal line. And then if you were to find the difference in the y's, since they have the same y values, you would get a 0 in your numerator, thus giving you a slope of 0. Okay, so there are 3 forms of linear equations. There's point slope form, slope intercept form, and general or standard form. And often the form that we use is going to be dependent on what information they give us in our problem. So point slope form, in order to write an equation in point slope form, we need a point and a slope. So we need a point and a slope. And point slope form looks like this. So we would have y minus the y coordinate of the given point equals your slope times x minus the x coordinate of your given point. So when you're trying to write an equation in point slope form, you would basically be filling in this piece of information, this piece of information, and that piece of information from what they give you there. Okay. Slope intercept form is probably the most common form or the most popular form. It's this y equals mx plus b, where again, the two things that you're looking for in this equation are m and b. M represents the slope, and it says b is the y-intercept, but a better description of b is the y-coordinate of the y-intercept, because the y-intercept is a point. It's a point that has an x-coordinate of 0, and then the y-coordinate would be that value of b. And then lastly, general form is what our book calls it, but we typically would refer to it as standard form. Standard form is this here, a times x plus b times y equals c. And there are a couple rules about standard form. First and foremost, a, b, and c must all be integers. So that means they can't be fractions or decimals. Your leading coefficient must be positive, and typically we have the variables on the left and your constant there on the right. And that is general or standard form. All right, so let's go ahead and look at how we can use some of these in a couple problems. So in this problem, it's asking us to write our equation in slope-intercept form. That's that y equals mx plus b form, given this information. So what do we know? Well, the slope is 3. That means m is 3. And we have a point 2, negative 3. Or sorry, negative 2, 3. The negative 2 is my x. The 3 is my y. So if I'm referencing this equation here, it's y equals mx plus b. What do I know? Well, I know m is 3. X is negative 2. I know y is 3. So I need to know b. I need to know b, because remember, when you're trying to write an equation in standard form, we should be replacing m and b with numbers. We already know m. We need to find b, and that's exactly what we're going to do here. So that's going to be 3 equals negative 6 plus b. Add 6 to both sides to get that b equals 9. Last thing we need to do is put it all together to write our equation. So it's going to be y equals our slope, which was 3 times x plus 9. And that would be our slope-intercept form equation of a line that has a slope of 3 passing through the point, negative 2, 3. All right, this is our last example here. Again, it wants us to write our equation in slope-intercept form, and we have these 2 points here. So let's write first, slope-intercept form. We need to at least know the slope, and then we need 1 point to write your equation. So let's find the slope. So we have 2 points. Remember, if we go back to that first slide, we can find the slope by taking the difference in the y's in the numerator divided by the difference in the x's in the denominator. So let's go ahead and do that. Your slope is in the numerator. It's the difference in the y's. So I'm going to, again, start with this. So 2 minus 4 divided by 4 minus 3. There we go. That's right. So 2 minus 4, that's negative 2. 4 minus 3 is 1. So our slope is going to be negative 2. So if we're trying to write our equation in slope-intercept form, so again, that's y equals mx plus b, we can do it one of 2 ways. So we can take the slope and either of the points that we know, we could take either this one or this one and plug in for m, y, and x and solve for b. Or another option is to take your slope and one of your points, put it in point slope form and change it. And I'll show you both of those forms, or those methods. So first I'm going to do the slope-intercept form method, just kind of plugging straight in. And I'm going to use that one. So my y-coordinate there and my x-coordinate there. So y is 2. So 2 equals our slope, which is negative 2, times our x, which is 4, plus b. So that's 2 equals negative 8 plus b. Add 8 to both sides to get that b equals 10. And then put it all together into your equation to get y equals negative 2x plus 10. So that should be our finalized equation. Now, the other method that we could have used is through point slope form. I'm again going to choose this point. So we're going to need a point and a slope, and we're going to transform it into slope-intercept form. So if we're using point slope form, remember it's y minus your y coordinate equals your slope times x minus your x coordinate. So we're going to replace the y coordinate here with y sub 1. So y minus 2 equals our slope, which is negative 2, times x minus the x coordinate. Distribute the negative 2 through. Whoops. Y minus 2 equals negative 2x. And then negative 2 times negative 4 is going to be positive 8. And lastly, we want it to look like this here. So we're going to add the negative, or add 2 to both sides. So you're going to get y equals negative 2x, and then 8 plus 2 is 10, which matches what we got here.